Today we're going to finish up our chapter 1.7 notes. In 1.7 we were talking about completing the square. Example 1 was solving for x when you're already in the perfect square trinomial. Example 2 was picking a value of c to make it a perfect square trinomial and then factoring it. And example 3 is actually completing the square, which is going to put those skills together. So example 3a, we have x squared minus 12x plus 4. The first step for these problems is that you're going to subtract the number over to the right so that you only have x's on the left. So I'm going to subtract 4. I'll have x squared minus 12x. And then I'm going to write a plus blank equals 4 plus blank. And this is like example 2 where I was adding a c value. This is going to be what my blank is, but in algebra, if we change an equation, whatever we do on one side, we have to do on the other. So just like example 2, this number is going to be b over 2 squared. In this case, my b is negative 12, which would be negative 6 squared, which is 36. So I'm going to add 36 to both sides. Sorry, this should be a negative 4. So then I'll have x squared minus 12x plus 36 equals negative 4 plus 36 would be 32. All right, this is now a perfect square trinomial. It's in the form a squared minus 2ab plus b squared. So my a here is x, my b is 6. It's going to factor as x minus 6 squared equals 32. Now this looks like example 1. I'm just solving for x. So I'm going to take the square root of both sides. So I'll have x minus 6 equals plus or minus the square root of 32. 32 is divisible by 16 and 2. So this will simplify as x minus 6 equals plus or minus 4, which is my square root of 16, times the square root of 2. Add 6 to both sides, so I have x equals 6 plus or minus 4 root 2. So that is completing the square. It's a couple steps, but it's not too bad. Let's look at example B. So I have x squared minus 10x plus 1. So again, I'm going to subtract 1 from both sides. So then I'll have x squared minus 10x plus my blank equals negative 1 plus blank. This is going to be my b over 2 squared. In this case, b is negative 10. So I have negative 10 over 2 squared, which is negative 5 squared, which is 25. So I'm adding 25 to both sides. So I will have x squared minus 10x plus 25 equals 24. Again, this is a perfect square trinomial. It's in the form a squared minus 2ab plus b squared. So my a here is x, my b is 5, so this will factor as x minus 5 squared equals 24. I can take the square root of both sides. So then I will have x minus 5 equals plus or minus the square root of 24. 24 is divisible by 4 and 6, so 4 is my perfect square. Square root of 4 would be 2, so this will clean up as x minus 5 equals plus or minus 2 root 6. Add 5 to both sides, so I have x equals 5 plus or minus 2 root 6. All right, example C. So example C, we have an additional first step here. We have 2x squared plus 8x plus 14. When you're completing the square, you need this x squared to be by itself. So in order to do that for this one, we can just divide both sides by 2. So we will have x squared plus 4x plus 7 equals 0. The 2 completely goes away because normally it would show up over here, but 0 divided by 2 is 0. Then I will subtract 7 from both sides. So I have x squared plus 4x, and then plus my blank equals -7 plus blank. This is going to be my b over 2 squared. B here is 4. 4 over 2 is 2. 2 squared is 4. So I'm going to add 4 to both sides. So I have x squared plus 4x plus 4 equals -3. This is a perfect square trinomial in the form of a squared plus 2ab plus b squared. So my a is x and my b is 2, and it's going to be a plus, so it's squared equals -3. We can take the square root of both sides. So I have x plus 2 equals plus or minus the square root of -3. Remember, now that we have negative square roots, if those happen, pull out an I. So you have x plus 2 equals plus or minus I times the square root of +3. Subtract 2 from both sides, and you have x equals -2 plus or minus I square root of 3. All right, D, so this is as ugly as it can get here, or one of the uglier ones. We have x squared plus 3x plus 14 equals 0. So I'm going to subtract 14 from both sides. So I'll have x squared plus 3x, and then plus my blank, equals -14 plus my blank. Now the reason this is ugly is because our b term is odd. So 3 over 2 is a fraction. It's going to stay a fraction, so I'm going to make this 9 over 4. But that's what I'm going to add to both sides. So then to add on the right side, I need to make 14 into a fraction over 4 because I want to combine those terms. So in order to do that, that is the same as multiplying 14 by 4, so you have -56 over 4. Again, you can check that real quick. -56 divided by 4 is -14 plus 9 over 4. So now a couple things. This is a perfect square trinomial. It's again in that positive form. It's a squared plus 2ab plus b squared. So this will factor to be x plus, and now here it's really nice to have this step because it's just that number. 3 over 2 squared equals -56 plus 9 is -47 over 4. So now when I take the square root of both sides, I have x plus 3 over 2 equals plus or minus, and then we can clean this up. We can split this into the square root of -47 over the square root of 4. Square root of -47, I'm just going to go ahead and pull out an I. And then 47 is prime, so there's no simplification I can do. And then it's going to be all over 2 because the square root of 4 is 2. So then I can subtract 3/2 from both sides. So I have x equals -3/2 plus or minus I times the square root of 47 over 2. I can leave it like that, or I can make this into one fraction, kind of how we've been writing these. Since they're both over 2, you can write this as x equals -3 plus or minus I times the square root of 47 all over 2. I will accept both of these. Either way is fine. So that's completing the square. Recall yesterday that I told you the whole purpose of us completing the square is so that we can solve these, but then also we were saying we started in standard form, and we've learned how to go back and forth to intercept form and then back to standard form, and we know how to go to vertex form, or from vertex form to standard form, and completing the square lets us do that last step where we can go from standard form to vertex form. So example 4 looks just like 3, except 3 was always set equal to 0, and in example 4 we have a y here. So this just wants us to write the quadratic function in vertex form. And it's basically the same. It is completing the square. There's one difference. Instead of bringing this 3 over, we're just going to leave it and kind of shove it to the side. So my first step for these is I'm going to have y, and then I'm still going to be adding something equal to x squared plus 6x. And then here's where I want to add something. So I want to make this my perfect square trinomial. And then I still have this plus 3. So then my added something is going to be that b over 2 squared. In this case, b is 6. 6 over 2 is 3 squared, which is 9. So I'm going to add 9 to both sides. And then again, ignore that plus 3. I'm not going to combine here. I just have y plus 9 equals x squared plus 6x plus 9 plus 3. This is my perfect square trinomial in the form a squared plus 2ab plus b squared, where my a is x and my b is 3. So this will factor to be y plus 9 equals x plus 3 squared plus 3. Now, unlike example 3, we're not solving for x. All I want to do is have this set equal to y. So I'm going to subtract 9. So I have y equals x plus 3 squared equals, minus 6. All right, so now we went from standard form to vertex form. Actually, on your Go Formative, it asks you for a further part. So this is the function, but then Go Formative also asks you for the vertex. So the way you're going to enter it on Go Formative is you'll write the function, and then your vertex is h comma k. Your h comes from here, and your k comes from here. Remember the h, we changed the sign, so it would be -3, but then the k, you leave the sign, so it would be -6. And that's how we're going to enter the answer on Go Formative. Part B, same thing, but now instead of a y, we have f of x. So you'll have f of x plus some number equals x squared minus 8x plus some number plus 17. My number here is going to be my b over 2 squared. In this case, b is -8 over 2 squared, which would be -4 squared, which is 16. So now I have f of x plus 16 equals x squared minus 8x plus 16 plus 17. This is now my perfect square trinomial, where this is a squared minus 2ab plus b squared. So my a here is x, my b is 4. So I have f of x plus 16 equals x minus 4 squared, and the minus comes from that sign right there, plus 17. I'll subtract 16 from both sides. So I have f of x equals x minus 4 squared plus 1. So that's the final function in vertex form, and my vertex then is positive 4, because you changed that sign, comma, positive 1. So that's writing the quadratic function in vertex form from standard form. The last skill we need to talk about, actually we encounter in this story problem here. So recall we can use quadratics for distance formulas, and oftentimes these story problems, it's really handy to have them in vertex form. So the height y in feet of a baseball t seconds after it is hit is given by the function y equals -16 t squared plus 96t plus 3. So I want to put this in vertex form because I want to find the maximum height of the baseball. And if you think about it, the maximum height right here is coming from our vertex. It's the y of our vertex. So if I can find my vertex easily, then I can find that maximum height. So I want to write this as y, and then I'm going to add some mystery number. Actually, before I do that, so let's just consider this function, y equals -16 t squared plus 96t plus 3. Recall I said in example 3 we came across one where we could divide because you want this to be by itself. Well, we have an issue here. We have this -16. So when you have to factor out a number and this is not divisible, especially when you're making it into vertex form, what you need to do is you're just going to factor it from part of the problem. So you'll be left with a parenthesis here. This will become a minus 6t plus 3. And now here's the tricky part. When you're adding that blank now, the way we're adding it is that you're going to add a number, but then you have to multiply it by whatever you pulled out. Okay, and you only do that for the right or the left side. And over here, you don't have to do that because the thing you're adding inside of the parenthesis. So on Go Formative, you have 2 problems that do this and then a story problem, so a total of 3 problems. But the key here is that this number right here shows up there when you add it, and then it doesn't show up here. So the number I want to add comes from my b over 2 squared. In this case, b is negative 6. Should be negative 3 squared, which is 9. So I'm going to add 9 to both sides. But then on the left side, this is going to be negative 16 times 9. So I'm actually going to have y minus 144 equals negative 16, and then I have t squared minus 6t plus 9 plus 3. So now this right here is our perfect square trinomial. It's in the form a squared minus 2ab plus b squared, where my a is t and my b is 3. So I have y minus 144 equals negative 16 times, and then this will be t minus 3 squared plus 3. Now I'm going to add that 144 back. So I have y equals negative 16 t minus 3 squared plus 147. So this is now in vertex form, and specifically my vertex is at 3, 147. In the context of this problem, t is my time, and then the y is actually my height. So at 3 seconds, the ball reached 147 feet, which happens to be our maximum height. So we can say the max height is 147 feet. So those are more complicated ones, and I guess I'll just kind of highlight this step right here. Just make sure this only will happen when you're when you're setting a standard function into vertex form. So it happens on your number 10, 11, and 12. With your homework, if you have any questions, please let me know as always. And I'll be monitoring your progress as well.